So what we have here is a darkness sensing LED using a photoresistor along with a Wheatstone bridge circuit. And the way that works here is where we have our power supply running in with a Wheatstone bridge. The resistors are neither in series or parallel. It's complex is what they call it. And that is because you have one path for electrons to enter and one path for them to exit. However, there are multiple paths for them to move around in between those 2 points. And the best way to visualize this in my mind is to actually start getting rid of paths. So if we get rid of this lower path here, we can see that electricity cannot even flow and back to the source here. There's no path for it to do that, so no matter what, it's going to take this path. And so if we do the same exact thing here with the other one, we'll see that it's just always on because it cannot go around the LED. It actually has to travel through it to get back to the source here. So when it is all together, and this is our photoresistor here, by the way, which I have, it should be 2K ohms here, just so that it matches the other ones. So now we have 4 2K ohm resistors with an LED in the middle. Our input is a 9-volt battery. We see that it's balanced on either side with 4.5 volts, and this photoresistor here changes resistance based on the amount of light that it is exposed to. So as I decrease my light source here, by decreasing the amount of light that it is exposed to, we see that it goes from 4K to 5K, where it was at 2K, so it was all balanced. 3K is not quite enough to turn that LED on, and right about 5K is when it starts to turn on, and it's a little bit hard to see, but it gets a little bit brighter over time, and it kind of stops. It looks at about 10K ohms. And as we adjust the darkness that the photoresistor is exposed to, or the light I should say, we can see the difference in the volts on either side, and that actually helps us make sense of why it takes the path through the LED, because as of right now, when they're balanced, it just flows around the LED evenly. As it becomes unbalanced, we can see that there is a higher voltage potential on one side of the LED than the other. So that side being our anode, that side being our cathode, our electricity is going to naturally want to flow through back to our source. And I actually have this circuit built, and one of the great things about schematics is they are not a physical representation of what the circuit actually looks like. It is just a logical representation of the path that electricity will take. So this is my Wheatstone bridge, and as we can see, I've got my photoresistor here. I've got a lamp shining direct light onto it, and all I have to do is take my hand here and put it in between the light and the photoresistor here. That light comes on because, once again, now that photoresistor has more resistance to it, there is less voltage on that side, so on the other side of that Wheatstone bridge there's a higher voltage, so it's going to want to jump through that LED and make up that difference there. And just as simply as taking your hand out of the light and exposing it to light again, what that does is that decreases the resistance there, allows electricity to flow through, that balances it back out, and there's no longer a difference on the either side of the LED, so it turns itself off. Hopefully this video was informative for you.